Okay. Bismillah ar-Rahman ar-Rahim. We'll start chapter 11, which is about series methods for differential equations. What's the problem? And we'll deal with such problem. What happened in chapter 5? In chapter 5, we dealt with nth order differential equation. But with what? With all of these coefficients are constants. So we can do the method we did in chapter 5. Now, in this chapter, we're talking about differential equation where we have some of the coefficients are not constant. And by the way, also if it is constant, we can solve it. And I'll show you an example. This is not a differential equation with constant coefficients. So we need a way to find the solution, which is through the series solution. Or in 11.2, we'll talk about power series solution. But 11.3, we'll talk about series solution. Okay. Let me just give you a review or the things we need about this series solution. We know from calculus what's the meaning of power series in x minus a. It's summation Cn x minus a all to the power n, which is C0 plus C1 x minus a, C2 x minus a square, and so on. This is, we say, power series centered at a. If a equals 0, then it will be centered at 0, and we have this summation of Cn x to the power n, where n running from 0 to infinity, which is C0 plus C1x plus C2x square, and so on. Actually, this is our consent, because we will do the things at x or around x equals 0. We know that the power series will define the functions. Power series will define functions. That means what? Yeah. Let me see it now. Yeah. That means I can write this power series as a function f, whose domain, what's the domain of this function? Is the interval of convergence of the series. That gave me what? Into this, since it's a function, I can differentiate it. I can integrate it term by term. We are concerned about the derivative. So if y equals summation, this should be 0, sorry. Cn x to the power n. That will be C0 plus C1x plus C2x squared plus C3x cubed. And so on. Now my y prime, be careful here about y prime. My y prime should be n equals 0 to infinity, same starting point. Then the derivative of this. What's the derivative of this? It will be n Cn x to the power n minus 1. You notice something. If n equals 0, because of this n, that will be 0. So this series, I can make it, it's the same series as n goes to 1, starting from 1. Times Cn x to the power n minus 1. Okay. So because of that, he wrote it n equal 1. For y double prime, what I will get? I will get n minus 1, Cn x to the power n minus 2. So at n equals 0, this expression will be 0. At n equal 1, this expression will be 0. So I have my starting point from what? From 2. Notice here from 2, here from 1, where the original series is from 0. We need this later. The next things, just to remind you about the interval of convergence, is a set for which set of ordinary numbers x for which the series converge. We have 3 cases. If r is positive, then we say the power series converge for this interval and diverges for x minus a greater than r. Also check the endpoints. This is what we usually do in Math 102, but just for your information. If r equals 0, it means what? We are concerned, I have x minus a less than 0. So we are concerned only about x equal a. That has no meaning. Okay, so the power series converges only when x equal a. If r equal infinity, then it means it converges for all real numbers. Okay, just to remind you about what's the meaning of interval of convergence, which is, we say it here. We say that in this place. Mainly what we need to do the calculation, I need this. How to find y and y prime and y double prime. And I need this theorem or this property. It's saying what? If you have summation of Cn, let me make a equal 0, x to the power n, where n equals 0 to infinity. This is what? If we look at it, let me try to explain it here. Summation of Cn x to the power n, where n running from 0 to infinity. That is what? C0 plus C1x plus C2x squared plus C3x cubed plus Cn x to the power n plus and so on. Notice, I know that 1 x squared, x cubed, x to the power n, all of these are linear independent. So if this is equal to 0, that means what? All coefficients should be 0. That means C0 is 0, C1 equals 0, C2 equals 0, and so on. So I have Cn equal 0. This is if a equals 0, if a equal any value, it will be the same idea. Since these functions, this is C0 times 1 times 1x, x squared, x cubed, all of these are linear independent. So if this expression equals 0, then all the coefficients should be 0. One of the things which we need is how to deal with the summation index. Also, if you have two things, if we have the power is different and the summation index is different, how to make it as one power series or as one power series. Okay, there is a strategy to do that. You need to follow. I mean, you know, if you do this, you do that, maybe you return back. So you need like a strategy to do so that it can be done clearly. You don't have you don't mix the things. So the strategy is like this. I will go to the first one. I want the power to be the same. The power to be the same. So I'll call k equal n minus 2. And this summation, I'll change everything in terms of k now. I let k equal n minus 2. It means n is k plus 2. Okay, so if we come to the summation, n is 2, so I have k plus 2 equal 2 to infinity. That means what? If k plus 2 equal 2 to infinity, I take 2 to the other side, so that means k equal 0. Now n is what? K plus 2. N minus 1, I have k plus 2 minus 1, which is k plus 1. Cn, so write c, k plus 2. X to the power k. I'll do the same thing here, and I will let k. We'll also use the same variable. I mean, this is just a summation. These are dummy variables. If I put instead of n, g, it will be okay. M, anything, it will be the same. So now let k equal n plus 1. And so that n equal k minus 1. So this series, or this summation, I have k minus 1 equals 0 to infinity. Or I can say k start from where? From 1. And change the rest Cn, it means ck minus 1, x to the power k. So this equals to that. Now I fixed the power. Is the same. As I said, this k, you can put any other variable, but usually we use the same so that we can see it easily. Now we fix the power. Okay. Now I need to fix what? I need to fix the summation. This is starting from 0, this is starting from 1. So what I will do, I will use the first one, 0, then the rest will be starting from 1. So if k equals 0, what you will have? You have 2, 1, C2, x to the power 0, plus what is the remaining? K equal 1. Since I use k equal 0, the next one, it will be k equal 1. The rest is the same. As I said, this is just a procedure you need to follow. Now, if you notice, I have now the power is the same, and also the starting index is the same. So it means these two series, I can combine them in one. So these things will have what? I have this is 2 times 1 times 2 C2, x to the power 0 is 1, plus, let me write it here. That will be 2 C2 plus summation k equal 1, k equal 1 to infinity of what? I combine these two, k plus 2, k plus 1, ck plus 2. I can take x to the power k common factor at the same time, minus ck minus 1, all to the power x to the power k. And this is my answer. So combine now these two series into one series, plus a value or something. Yeah, oops, plus something which is no. Yeah. Okay. Now, let me do this example. What is nice about this example, it's something I know. What is the solution of this? Yeah, this we know it. It's what? dy over dx plus y equals 0. So I have dy over dx equal minus y. In other words, dy over y equal minus dx. So ln absolute value of y equal minus x. So y equal is minus x d plus c. Yeah. So my solution is, or I can make it, yeah, this is, when I do the integral, this is plus c. So I have c e to the power minus 6. So this is my solution, which we know it from. Yeah, so let me just make it clear. This is minus x plus c. So y will be c is minus x, different c, different than this, e to the power c, which is equal to c. Yeah, we know that from yeah, this is just separable, which is the first section or the first method to solve differential equations, first order differential. Okay, which is the easy one. Now I will solve this problem using the power series solution. This is an easy one. So I show you what I mean, the procedure we need to do to solve it, and it's the same when we go to the second order differential equation. When it comes here to the second order differential equation, we'll do the same procedure. In general, the same procedure. Okay. But this is, I think it's a good idea to start with an easy one to see what's going on. So now this is my solution. This is my solution. By the way, in this solution, series solution or power series solution, we are concerned only about this constant. We are looking for this constant. Okay, so I have y equals summation n equals 0 to infinity Cn x to the power n. Okay. Yeah, to get the constant, I need to substitute into the equation. Means what? Means I need to find y prime. We did y prime before. This is y prime. Don't forget, the summation starts from 1. So I have y prime is summation n equal 1 to infinity n Cn x to the power n minus 1. So y prime plus y will be what? Will be summation n equal 1 to infinity n Cn x to the power n minus 1 plus summation n equals 0 to infinity Cn x to the power n. Okay. Now, what I need what I did here. And we will try to combine the two series into one. Okay. Okay. So what was my trick? If you remember, what was the trick we use? We'll try to make the power the same, and we'll see now the index, what will happen with the index. Okay. So in this one, I let k equal n minus 1. Here I let k equal n. That means here n is k plus 1. Here n equal k, which is clear. So that will be summation. So n plus k plus 1. So I have k equals 0 to infinity. Okay, n is k plus 1, k plus 1, ck plus 1, x to the power k. Okay, now the next one, we'll make it k equals 0 to infinity, ck x to the power k. What happened? If you look at it, you'll see that now the powers are the same, and also the index will be the same, which is not the case when we will go to the second order differential equation. No, we don't have, both are the same. Yeah, we'll show it to you. Then we'll do the second trick, which is I open the index. But now in this case, they are the same. So what I will do, I'll combine them in one series. That will be summation k equals 0 to infinity, k plus 1, ck plus 1, plus ck, all times x to the power k is equal to 0. Okay. Yeah, why it's equal to 0? Because this is the equation. I'm starting with y prime plus y. I'm rewriting it in a different way. So this is will equal to 0. So now if you look at this, the second thing, or the first one we saw, the identity property. If I have Cn times x minus a, or x to the power n, like this one, it's equal to 0. It means all of these coefficients should be 0. So that means in this case, what we have, I think, let me back to this. That means I have k plus 1, ck plus 1, plus ck should equal to 0. Where k running from where? Where k running from 0, 1, 2, 3, and so on. Okay. Now this one I can rewrite it. So I have, this is, by the way, this is, they call it recurrence relation. This they call it recurrence relation. Okay. Sometimes in the exams, especially, because it's a long procedure, he will give you the differential equation. He will ask you only about the recurrence relation, which is you need to calculate it a little bit. You need to adjust it a little bit. I would say ck minus 1 equal what? Minus ck over k plus 1. So it's minus 1 over k plus 1 ck, where k running 0, 1, 2, and so on. Okay. So this is my recurrence relation. What I will do now, I will try to check when k equals 0, what will happen, when k equals 1, what will happen, and so on. So we'll go to this. I have the recurrence relation. That is -1 over k plus 1 ck. So k equals 0, what will happen? C1 equal -1 over 1 C0. So I have minus C0. K equal 1. C2 will be -1 over 2 C1. What is C1? Is minus C0. I'll write everything in terms of C0. Now this is minus times minus. That will be 1 over 2 C0. K equal 2. C3 will be what? -1 over 3 C2. That will be -1 over 2 times 3. I will leave it like this. I will not do the product. I'll tell you why later. K equal 3 C4 is -1 over 4 C3, which is equal what? -1 over 4 C3 is this. That will be plus, minus times minus, and this is will be 2 times 3 times 4, and so on. And we'll continue like this. If you want me to do one more, I think it's very clear, but since it's the first one, let me do one more. Well, -1 over 5 C4, and then it will be -1, 2, 3, 4, 5. Okay. Now, if you look at these ones, this is what? -1 over 1 factorial C0. Yeah, in this example, I will try to write the solution in terms of a function. So I will try to, since I know it will be e to the power -x. So I will try to get this e to the power -x. Yeah. By the way, without that, so let me go back to this color. Without that, what will be my solution? We know that my solution is y equal summation Cn x to the power n. This was my solution. If you open it up, that is what? C0 plus C1x plus C2x squared plus C3x cubed plus C4x to the power 4 plus so on. So now if I plug these numbers, which I got C1, C2, C3, C4, if I plug it in this expression, what you will see? You will see that this is C0. C1 is what? Oops. C1 is, yeah. Before that, maybe I will, since I want to get the solution, I don't want to get only the series. I want to get the exact solution. So let me go back to this one. Yeah, this one, if you look at it, this is what? This is 1. What is 2? 2 is 2 times 1, which is 2 factorial C0. This one is -1, 2 times 3. That will be 3 factorial C0. This one is 1 over 4 factorial C0. And this one -1. I forget the C0 here. Yeah. -1 over 5 factorial C0. Now plug it here. You see what? C0 plus minus C0x plus 1 over 2 factorial C0. Am I right? Yeah. And then I have what? Plus or minus -1 over 3 factorial x cubed plus 1 over 4 factorial x to the power 4. By the way, if we want to find Cn will be what? Which will happen at k equal n minus 1. Cn, you can see it. I have C5 is -1. Oh, yeah, so it is coming minus plus minus plus minus. So with the With the odd ones, I'm getting minus. With the even ones, I'm getting plus. So I can write this minus 1 to the power n, just the sign. And this is n factorial x, yeah, times C0. So this work out with all of these ones. Okay, so I can write this plus what is will be the nth term. It will be minus 1 to the power n over n factorial, coming with x to the power n. Okay, plus the rest, which is what? Don't forget the C0. So if I take C0 as a common factor, what's the remaining? 1 minus x plus 1 over 2 factorial x square minus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the power 4 plus or minus until we reach what? Plus minus 1 to the power n over n factorial x to the power n plus the rest. What is this? If you remember the format of the series, this is e us minus x. Don't forget, e to the power x is summation. Yeah. X to the power n over n factorial. So we're n running from 0 to infinity. Yeah. So this will be, so implies in e minus x will be the summation n running from 0 to infinity minus 1 to a power n over n factorial x to the power n, which is the case here. Actually, this series, you can write it as C0, then summation n equals 0 to infinity of this term. Okay. Yeah. Yeah. Let's just summarize what we did. Let's summarize what we did. If this one clear, yeah, good one. What we did. Easily, we have y, we'll find y prime. Substitute to the equation. You get a series with different index with different powers. Try to fix them. Make it the same power and the same index. So we get this. That implies what we give something times x to the power k is equal to 0. That means this coefficient should equal to 0. So we are getting what's called recurrence relation. We rewrite it in this format. Now I need to find these c's. So I have k 0, 1, 2, 3. It depends on the problem. I have this relation, and I have k is 0, 1, 2, 3, and so on. So I substitute. K equals 0, you get C1. I write everything in terms of C0. In this case, C2, I get this, C3, and so on. So I have a format. No need to find the format in the other problems, but this is since I know the answer. I want to get it. Then you just plug these numbers, this calculation, where C1 equal this, C2 equal this, plug it into the solution. This is my solution. So it's C0, I'll write C0. C1, it's minus C0, put it there. There's 1 over 2 factorial C0. Don't forget there is x squared here. Yeah, and so on. That's the way to solve it. Easily. You have the format of the answer. I'm looking for these C's. Plug it. Rewrite the index, the power, readjust the power and the starting index to make it one power series. You get what's called recurrence relation. Then substitute k, and then just substitute everything in this. What you get from substituting k into this solution after you open up the series. That's it. You get the answer. And this is what we will do in the next in the second order differential equation. We'll show it to you later. But this is mainly the idea. So I'm doing it with an easy example so that you see what's going on. Okay. Now we'll go to the 6.2 or 11.2. Sorry, this is 11.2, not 6. Yeah. Ordinary and singular points. We have what's called ordinary and we have what's called singular points. We say a point x equal x0 is said to be ordinary point. By the way, we are working with this differential equation. Okay. So we look at these functions, or we'll find, we write it in standard form. So I divide by A2, and I get what's called P and Q. Actually, we don't need have it A1 over A2 of X, and Q is A0 over A2 of X. Okay. So we look at these coefficients, P of X and Q of X. If they are analytic at X0, what's the meaning of analytic? They can be represented by a power series. They are differentiable, nth order differentiable, or they are differentiable many times or n times. Can be differentiable everywhere. I mean, you can find the first derivative, second derivative, third derivative, and so on. If they are analytic, we call this point ordinary point. If they are not analytic, then we call it singular point. Let me do it by example. Look at this one. Y double prime plus y equals 0. Okay, the first one. Y double prime plus, we don't have y prime, so it's 0 y prime plus y equals 0. What is my p of x? 0. My q of x? 1. These are differentiable everywhere. So they can be represented by a power series. You know, when you do the power series, you want to check the end derivative. So it means this, all points are ordinary. All points are ordinary. And the same thing for this. For constant coefficient, all points are ordinary. Let me go to this one. Y double prime plus a to the power x. What is p of x? A to the power x. What is q of x? Cosine x. And this is all the way, they are analytic. I can differentiate this as much as I want. I can differentiate this as much as I want. So these are analytic at every number x. So that means all numbers or all points are ordinary. Let me do this one. Now, what is p of x in this case? It's 1 over x. What is q of x? X over x, which is 1. Now I have problem at 0. So these are analytic, except P. For P. For Q is analytic. Q is okay. P is analytic, except at x equals 0. So x not equal to 0, this is ordinary point, and x not equal to 0, then x equals 0 will give me what? Singular point. Okay. In this case, you need to be careful. This is p of x, ready, and this is q of x. But be careful. This one is defined when x is greater than 0. So I'm concerned only about this point. Otherwise, the function is not defined. So when is this analytic? So I have ordinary if x is greater than 0. By the way, what we are concerned about actually in this section is only polynomial coefficients. But that was the general things. If it is polynomial coefficient, then it will be easier. Why? Because I have a2 of x, y double prime, plus a1 of x. This is the general one. So what I need? I need p of x and q of x. So assume I have no common factors. Huh? No, I do the cancellation if there is a cancellation. So I need a2 of x not equal to 0 to have what? Ordinary point. But if a2 of x is equal to 0, it will be singular. So this is the rule. This is my rule for the polynomial coefficient. If it is in this format, number x equal x0 is an ordinary point if a2 at x0 not equal to 0. If a2 at x equal to 0, we call x equal x0 what? Singular point. So in this case, I don't care about all of this. I care only about what? a2 of x. When this is equal to 0, so I have x equal plus or minus 2. So these are what? These are my singular point. So I have singular point at x equal 2, at x0 equal 2, and x0 equals minus 2. All other points are what? Are ordinary points. The same thing here. I'm concerned about what? I'm concerned only about this. So I have a2 of x is x minus 1 times x squared plus 9, make it equal to 0. So I'm getting what? X equal 1 and x equal 1 or x equal plus or minus 3i. So it means what? Singular point. What are singular point? x0 equal 1, x0 equal 3i, x0 equal minus 3i. All other points, oops, all other points are ordinary. Now, in this section, which is 11.2, we are concerned about the ordinary point only. We are concerned about what? Ordinary point. So if x equal x0 is an ordinary point of the differential equation, we can always find two linear independent. Look, if I have x equal x0, ordinary point, right away, we can always find what? Two linear independent solutions, second order. My equation, don't forget my equation, a2 of x, y double prime plus a1 of x, y prime plus a0 of x, y equals 0. I can find two linear independent solutions. In which format? In this format. Not only that, this is power series solution, and it will converge at least in some interval defined by this. x0 is my ordinary point. What is r? Capital R is the distance from x0 to the closest singular point, to the closest singular point. But sometimes in the exam, they ask only about the minimum radius of convergence, which is the R or the interval. Okay, so how to find how to find that? How to find the interval or how to find R? I will do it in this example. Then we'll do 2 or 3 examples about that, and then we'll go to find the solution. Okay. Now, to find that, I need to find the singular point first. What are the singular points here? In this case, I have a2 of x with the x squared minus 16 equals 0. So x equal plus or minus 4. So singular points are what? X equal plus or minus 4. Okay. Now he gave me part A, x0 equals 0. x0 equals 0. Is this one singular or ordinary? I know these are the singular points, plus or minus 4. Is it part of it? No, because all other points are what? Ordinary. So what? This one will be ordinary point. So what will be the interval? The interval of convergence, will be x minus x0, which is in this case x minus 0, which is absolute value of x, less than capital R. What is R? R is the distance from x0 to the closest singular point. It means what? I have x0 equals 0. I have two singular points. I need to find the distance to 4 is my first singular point, and to minus 4. What will be the distance? Distance here from 4 to 0, it is 4. The distance here will be 4. So what is the closest? They are the same. So R equal what? Equal 4. So what's the interval of convergence? Let me call it IC. The interval of convergence will be what? Absolute value of x less than 4, which is this one. Okay. Now let me move to the next one. x0 part B. x0 equal minus 1. Okay. So what's my interval of convergence? It will be x minus x0, which is x minus minus 1. That will be x plus 1 less than capital R. What is my capital R? Then I have x0 equal minus 1. Okay. And I want to check the distance up to 4 and the distance up to minus 4. Be careful here. What will be the distance up to 4? Minus 1 to 4, the distance equal what? 5. What's the distance here? The distance is 3. So what's my capital R? The minimum of this, since I have the closest singular point. The distance which is the closest. So R equal 3. So my interval of convergence will be absolute value x plus 1 less than 3. That's my interval of convergence. Okay. Let me do more examples. Now I have this one. Yeah, be careful with this one. What are the singular points? I need to solve this equation. A2 of x, which is x squared minus 2x plus 5 equals 0. This is what? Yeah, I need to solve it using what? It's the quadratic formula. I have 2 plus or minus square root b squared 4 minus 20 over 2. This is what? 2, 16. So 2 plus or minus 4i over 2. Yeah, I have an I here. That will be 1 plus or minus 2i. So what are the singular points? X equal, they are 1 plus 2i and 1 minus 2. These are my singular points. All other points are ordinary. Yeah. Don't forget in this one, yeah, in this one, this is ordinary, huh? Why it's ordinary? Because the singular points only x equal plus or minus 4, and minus 1 is not part of that. Okay. So now let me do part A. x0. This is what? Very clear ordinary. What will be the interval of convergence? X minus x0, which is 0. So I have absolute value of x less than capital R. How to find R? I need the distance between 0 and 1 plus 2i and 0, 1 minus 2i. How to find the distance? Okay. Yeah, consider it this way. Now consider the 0 to be 0, 0. So I have real part and imaginary part, which is the same, 0, 0. This one, 1 and 2. This one, 1 and minus 2 as the real part and imaginary part. So distance 1, which is the distance from 0, 0 to 1 and 2, the distance between these two, that will be what? Square root, difference of the x values. We know the distance formula, 1 minus 0 square plus 2 minus 0 square. And that give me what? That will be square root 1 plus 4 square root of 5. I'm doing it in too much details. Second, that will be 0, 0 to this point, 1 minus 2. Consider like a point in the real line and the imaginary line, okay? That will be the distance formula, which is 1 minus 0 square plus minus 2 minus 0 square, which is the same thing. Square root 1 plus 4 equals square root of 5. So what will be my capital R? They are the same. It's capital R square root of 5. So it's my, what is the interval of convergence? Absolute value of x less than 5. Now let me do the second one. Part B. What is my, this is my x0 minus 1, which is the ordinary point, very clear. Okay, so what's the interval? It will be x minus x0, which is x plus 1 less than r. How to find r? Have the point minus 1. I want to see the distance to 1 plus 2i and 1 minus 2i. I'll do the same trick. So this is the point minus 1 and 0. This is the point 1 and 2. This is the point 1 and minus 2. So the first distance with this one, this is 1, this is 2. Okay. That will be what? 1 minus 1 all square plus 2 minus 0 all square. And that equal to 1 minus that will be 2. So I have 4 plus 4 square root of 8. D2 will be the same thing exactly. So I have what? Now with this one, so I have 1 minus 1 square plus minus 2 minus 0 all square. That will not make a difference. That will be square root 4 plus 4. So what's my R? They are the same. So R equals square root of 8. So my interval of convergence, x plus 1 less than the square root of 8, which is this one, which is correct. Now, let me do this one quickly. Yeah. So what is my singular point? I have a2 of x squared plus 9 equals 0. So I have x equal plus or minus 3i. These are the singular points. All other points are ordinary. Now, he want to check the thermodynamic coordinate by term as a series solution in powers of x. So that means x minus 0. If it is in powers of x, I have x minus x0. So this is going to be my x0. So I need to check. That means I need to check about what? For this one, let me call it, this is A and this is B. For A, I'm checking x0 equals 0. And it's a ordinary point. Why is it ordinary point? Since this only singular point are plus or minus 3i. All other points are ordinary. So what is the interval of convergence? That will be x minus x0, which is x less than r. How to find r? I have 0. I want to do it to 3i and minus 3i. So what is this? This is 0, 0. And this is 0, 3. And this is 0 minus 3. This is the point 0 and minus 3. So what's the first distance? Got this one. This is 2. Yeah, very clear. That will be 0 minus 0 square plus 3 minus 0 square, which is 3. D2 is the same. So what is R? Initial, what is R? Will be equal to 3. Interval, absolute value of x less than 3. So the radius of convergence, he wants the radius of convergence. This is my R for the first one. He wants R actually, but also we can do the interval of convergence. Now, second case, which is x minus 4. So what will be my x0? 4. And this is the ordinary point. Why is it ordinary point? Because this is what he did. He wants the solution as a power series in this format, x minus 4. So that means x0, which is 4 in this case, is the ordinary point. So the interval of convergence, x minus 4 less than capital R. How to find R? I need 4 to 3i and to minus 3i. Do the same trick. 4, 0. This is 0, 3. And this is 0 minus 3. So D1 will be the difference of what? 0 minus 4 square plus 3 minus 0 square. And that will be what? Square root of 16 plus 9, 25, which is 5. D2 will be the same. So it will be capital R, will be 5. What will be interval? X minus 4 less than 5. Yeah, that actually would be my answer since you want the radius of convergence. Yeah, which is 5 in this case. This is R. Okay. Yeah, I think I'll stop here. What's the remaining? Yeah, what's the remaining is the how to solve differential equations. We'll do examples. Now, what I did in this video, I start this power series, the definition, and how to find y prime and y double prime using that. When I do the summation, as I said, usually we work about x equals 0. Now, also we talk about how to make the two sums or three sums as one sum. This is a procedure through K. I change the powers, and then I see the index. If I need to open one of them or two of them, we'll see what will happen. Now, and I did this example for y prime plus y equals 0, which is the same procedure. We'll see it later, also for the second order, where I don't know the answer. I know this is the answer is e to the power minus 6, and I show it to you. And then we'll talk about, we'll move to 11.2, where we define what's ordinary and singular through this analytic. Analytic means the function is differentiable many times. So we did this example where I have exponential is differentiable many times, cosine, the same thing. But if you have 1 over x, you need to be careful at x equals 0. There is a problem at x equals 0. Yeah. So this is we'll tell me what's, but what we are concerned about mainly is the polynomial coefficient in this course. We are concerned about the polynomial coefficients, and that will make our life easier. This is my differential equation. So how to control it? I will look at the coefficient of phi double prime. Equal to 0, give me singular point. Not equal to 0, give me ordinary point. Okay. Then we'll move to this existence of power series solution. If I have ordinary point, I want to find the solution about this ordinary point, then we can always find two linear independent solution of this format, which is power series format. Not only that, I can find the radius of convergence for this, where when this power series converge, which is x minus x0 less than r. What is r? The distance from x0 to the closest singular point, to the closest singular point. Yeah, and I did examples about find the minimum of radius of convergence. Usually there is a question about this minimum radius for convergence, not about, I mean, and then we'll talk about the solution, how they will come in the exam. But this is what we did until now. Let me stop this video, and then I will go in the next video in solving these solutions. Thank you.